IP address. Yeah, we have talked about IP address. When your computer is connected to internet, yeah, you're being given this IP address. Yeah, most of cases. Okay, the IP address is four numbers like A.B.C.D. We talked about this before. Yeah, A.B. There are four integers. Each one is between 255 and integer between 255 and 0, okay? B, so I'm writing down B, C, D, okay? Yeah, okay. So let me write a number here, 265, 8.32.5.6. Is this our IP address? Is this our IP address? No, why is that?
Because it has over,
This one, yeah? And how about this? 1.2.3. Is this a IP address?
No.
Why is that?
Because it only has 3 numbers.
Okay, how about this? 0, 1.2.3.4. Is this a IP address? Very tricky.
No.
No, yeah, why?
Because it has a, 0.
Leading 0. Unless it's 0, okay? 0.2.4.6. Is this IP address?
Yes.
Yes. Okay. Exactly. Okay, so we're given this. Okay, so we have removed the dot. So can you restore the IP address? Yeah. 255, 11133. So what's the valid IP address? It could be many. Yeah, it could be many. Ryan, you want to get this one? I have removed the dots from the original IP address. So what could the original IP address be?
255.255.111.33.
Okay, and this is one. And is there any others? And what could that be?
25.52.551.
Huh?
Wait. 255.255.11.133.
Exactly. So there are two. Okay, very well done. So what's your thoughts about doing this? How do you find out there are two? How do you do it? I mean, what's your original approach? What were you trying to do like here?
So all I was doing is, so I just count how many numbers are they,
Yeah.
and they are 11.
11, yeah.
So
Yeah, exactly, yeah.
yeah.
Okay, so you count 11 now. Okay.
You know some information.
And then why you said 255 and then 255 and then it could be how did you find this actually? I just want to know how
Because I don't actually want to wait for 255.
Mhm.
Because I mean 255 is less than 256.
Mhm.
So it could be,
Yeah, it could be the valid answer and then you jump, yeah. You can jump, yeah, until you find it, yeah. Am I right?
Yeah.
Okay, so that's very good.
I mean, I obviously need the 255. Even though I could do like two, I can do 2, 5.
Yeah.
I can't do 5, 2, 5.
But you can do 5 too.
Yeah, but then I wouldn't have enough space to do all of them.
Yeah, and then you do 5. But look, it's more than 3, then that's definitely not possible. Okay, so you bring out a very important point is that we have to use all the digits. But we can't use too many digits, right? So we have to use all the digits, right? You can say 25, 52, 555, 101, 111, but we have, this 33. It can't fit into the last digit because it's too big, right? So each one has only 3, at most 3 digits, right? You can't have more than 3 digits because this 255 is the 3 digit. You can't have 4 digits, etc. Okay, and then. Obviously, in the middle, we have to check if it has leading 0, right? If it's leading 0, 1, this is not a valid digit, right? 0. You can only have one leading 0, unless it's a 0, right? If it's 0, that's fine. Otherwise, you can't have a leading 0. Okay, so our approach, yeah. So we can do this. Look, we can track. We can do this depth search backtracking, yeah. So we can try the first digit, current the next digit, right? We can try next digit, and then jump next digit, until we use all the digits, right? Yeah, we can go for this approach, okay? We can go for this approach. There's only one thing we need to remember is that when jumping over the digit, we have to check if it's a valid. If it's valid, if the is between 0 to 255, and if it's 0, it can only be represented as single 0. Okay, it can't have this 0 0 thing. Okay, for example, I can give you an example. 0. Okay, so 200 to 200, 255, 1 to 23. Okay, so can you restore this?
200 dot.
Yeah, 200.
Dot. 255 dot 12.3.
Yeah, it could be many, yeah, but yeah, it could be many. So for example, if you want to have a 0, you can only have 20 0, 20 0, 255, 1 2 3. That could be one example, yeah. But you can't have 20 0 2 55 and 1 2 3, yeah. This is not right, right? Yeah, this is not right. Yeah, because this 2 has the leading 0, which is not valid. Okay, that's very good. So so basically we are asking computer to do this search for us. So let's say define depth search. So by this depth search, so we can pass a parameter current, which is a list. Yeah, which is a list. So which is the list? Yeah, it's a list. So this list contains the number of the digit. At most it could be 4, right? There could be 4. So we can just first of all we need to check the length, the length of all the digits together. So n equals the sum length x for x in current. Okay. So this is a very useful thing to do it. So what does it mean? So for example, if this current is 1 2 3 3 4 5. Okay, for example, there are only 3 numbers here. So the length is 3 digits plus 2 digits plus 1 digit. That will be 6 digits. So n equals to 6. Okay. And then now after this, we need to check. Look, if the length of the current, yeah, if length of current equals 4, what does it mean? So we have already 4 digits, and then we have to check if n equals, okay, so here the original one, there will be a restore IP address, which we have a string, yeah, string. So if n equals the length of the s, then we put it in the answer. So let's put it in the answer here. Answer equals the list. It contains the list of IP address. Then we have to append answer.append. Now we want to convert. Okay, we want to convert list we want to convert a list to string. How do you still remember? Array of list. We want to make this 1 2 3 4 to 1.2.3.4. Do you know how can we convert it? From this is the list to here. Join by what? Join by what? Dots. Okay, so we can append join current. Yeah, right? Yeah. Okay, so now if not, then we just return, yeah, because it's not satisfying the requirement, and we can just skip. Okay, and then now we just have to look for the next digit. So the next digit will be for I in range. Yeah. Now we have nth digit. So we have nth digit from the string. So the string could be 1 2 3 4 5 6. Yeah. So for example, if we have 1.2.3 1 2 3. So there are only 3 digits. So we can try on the 4th digit here. Yeah. We'll try on the 4th digit. Right. So n is 3. We can try on the 4th digit. So that will be n on n. Up to what? To the n, right? So we can do this to the n. But the thing is that how many digits we can try at most? Do we have to try to the n?
No.
Y is how many digits? So now I'm at index I. So how many digits I can try for the next number? What's the maximum number of length? What's the maximum? What's the maximum of the digit? So what I mean is that look, I'm here, right? I'm here. I want to try the next digit. Should I try 3, 4, or 3, 4, 5, or 3, 4, 5, 6? Do I have to try 3, 4, 5, 6? No, right?
No.
Why is that? Because it's more than 3 digits. We can only try 3 digits and more. Yeah, 3, 4, 5. 3 digits. Because if it's 4 digits, it's definitely more than 255. That's what I mean, okay? So we can do this mean. We have this n plus 3 and all the length s. If it only has 2 digits left, then we just have to try up to the n, okay? Try to up to the n. And then the next digit will be what? The next digit, so x equals s. We start from the index n up to I plus 1. I plus 1 up to I, right? Okay. Then we have to check x, if x is the requirement. So if this is a string, yeah, we convert it to integer x. If int x is bigger than 0 and smaller than 255, n, okay? So if it's 0, okay, if it's 0, then we have to exclude the cases which is as the, this multiple zeros, okay? So if this is between this range, also if what? If length, if n length x, if it's bigger than 1, or x equal 0, okay? So we have to check if it's 0, okay? If it's 0, okay, so I have to write this one here. And if this is 0, or if it's bigger than 1 digit, and the first digit is not 0, okay? Then, okay, so look at this. If we convert this x string, this digit, substring, to integer, if it's between the 0 and 255, that's great. But we have to check one more thing. If it's 0, if it's a single digit, 0, or if it's more than 1 digit. But if it's more than 1 digit, then the first digit can't be 0, right? Am I right? Yeah? So this means that if it's a single digit, if it's a single 0, that's fine. Otherwise, if it has more than 1 digit, then the first digit can't be 0, right? Make sense?
Yeah.
And then in this case, then this is a valid point, so we can current append x, and then we can do this depth first search current. And then at the end, we need to restore the state, which is pop, right? So look, we want to do the depth first search, right? We want to do the depth first search. We pass this current. This is remember yesterday or the day before yesterday we talked about pass by reference, object reference. If the array is mutable, then what does it mean? It means that anything changed in the function will be impacting the value, right? Yeah?
It will change the whole value.
That's right. So look, we're changing this, the append. We're changing this list. Yeah? We're changing the list. We pass to the recursion. We pass it to search. And after that, we need to restore the state, right? So this is very important. Current.pop state. Pop. Okay. Current append and current.pop. And then in between, we pass the new state into the function. Okay. And then now we just return depth first search. We give it an empty list and then return answer. Yeah. Okay. Return answer. Yeah. Everyone, any questions so far? I mean, what have you learned so far today? What have you learned?
About IP code.
IP address, yeah.
IP address.
So what are we doing here? What are we doing here?
We're doing stuff.
You are doing stuff. Wait, great, yeah. Okay, so do you get it? Okay, let me write the. Okay, so the original one, yeah, 255. Okay, where is too noise? 255, 255, 11135. Okay, this is the original one. This is the original string. Okay, so how can we do this? Therefore, search empty list. Empty list. Empty list. N equal that will be 0, right?
Yeah.
Then if not, it's not equals 4 because the current equals 0 element. Okay, now for I equals from 0 to length s and mean 3. So the first digit will go from 2 to 255, right? Yeah?
Yeah.
Okay. So let's say if we go to the 2 and the next digit will be from 5, it can go to the 5. Okay, so it needs to take a while. And the third digit will be 5. And then the fourth digit will be 2, right? And that's it. Because but this length, the length only 4 digits is not equals to how many digits? 1, 2, 3, 4, 5, 11 digits, right? 11 digits. So it's not adding it, right? So the only two possibilities is 255, 255, 111, 35, or 255, 255, 11, 135. Yeah, as we talked about. Okay. So look, if we may here we may check the length. If the length of s is bigger than 12, so what does it mean? If the given string is more than 12 digits, do we need to do this backtracking? Yes or no? If this string is given like it's more than 12 digits, no. Right? Because there's no possible. If you divide it into 4 parts, then at least one of them is more than 3 digits, and that means that it's not possible. So we can just directly return an empty list. Why is that? This is called pigeonhole. You know pigeonhole principle. Yeah. Okay. I have 10 box. I have maybe 5 box. 5 what's the thing? What's the container that you put a pigeon in? What's that cage? Yeah. What is it called?
I think it is.
A cage. Okay. We have 5 cages. Okay. Eric, right? So we have 6 pigeons. 6 pigeons, 5 cage. So can I say that at least one cage will contain more than 1 pigeon? Am I right? What does it mean? Do you get it?
Yeah.
Ryan? 5 cage. If we want to put 6 pigeons in, there must be at least 1 cage has more than 1 pigeon. Am I right? How can you prove this?
Because you could put five
Yeah.
pigeons in the 5 cages and 1 pigeon in one of them. And 1 pigeon with with a buddy.
So how to? Okay. So for example, you want.
Like you can put one pigeon in each box.
Yeah.
And cage, and you have 1 left. So
You put it some anywhere.
So one of them has to have 2.
Well done. That's the perfect explanation. You can teach mommy. Yeah, this is pigeonhole. The same thing here. If we have 13 digits, yeah, 13 digits. We want to divide it into 4 parts. Eh? Yeah. A, B, C, D. Yeah. So what does it mean? Okay, look. For 13 digits, 4 parts. What does it tell us? One of them, at least one of them contains more than 3 digits, right? Yeah? 13 digits. Yeah? Make sense? So if one of them contains more than 3 digits, it's not a valid IP address. Right? Because it's more than 255, obviously. So we can return empty list here. Okay. So here, okay, so this part. Any questions so far, Eric? Right?
No.
Okay, that's it for today. Bye bye. Bye bye.